Thank you very much, and thank you for the stoic who still remained. My name is Maurizio Gibin, and together with Jacob, we prepared this presentation talking about footfall and in-app mobile phone data research at the CDRC. So first of all, a little bit of an explanation. What is the CDRC? It's the Consumer Data Research Center. It was established in 2014, and it's a collective of different universities, Leeds, UCL, University of Liverpool, and University of Oxford. I am Maurizio Gibin, I'm from UCL, and Jacob, who is in the panelist, is from Liverpool. We do quite a lot of work. We have several activities at the CDRC. We work with population data, we work with migration, but today I will focus on past and current research that we have been doing for the creation of research-ready data products using human mobility data. So what we do, one of our activities is the creation of research-ready data products. So for that, we use data from several sources, some of which are also commercial providers with which we have data licensing agreements. And while using this data, we produce research-ready data products that then we give to researcher through an application process that is managed by the CDLC itself. The level of this data, it depends on the confidentiality and on the data licensing agreement of the data providers. And we have three levels of security, let's say open, aggregated, and secure. And access to this data is regulated in different ways. Open data can be downloaded from the website, while research aggregated data needs to be applied for, as well as secure data, which contains very sensitive, highly sensitive data, can only be accessed through secure research environment and in situ labs. Just to provide a panoramic view of what we actually do. So today I will focus on two types of mobility data that we have at the CDRC available and in work. So first I will start with footfall data. Well, as our center's name says, we work with consumer data. So footfall data are very important, and in store location, for example, in analysis of performance of stores and so on. We can say that footfall is basically the number of people visiting or passing by a retail location. And there are different technologies involved into sensing how many people are passing in front of a retail location. One of the first, there are several ones. Well, one of the easiest one is just counting them, having a person that counts them. From other more sophisticated one of the first one used is the Wi-Fi passive signal probing. So we use a Wi-Fi router that sends a probe request, and then the probe request is analyzed, and from that derive counts. This is part of a work that has been done at the CDRC during the SSS Smart Sensor Street Sensor project at the CDRC. So with that, we located several devices in, as you can see here, a total of several locations around UK. And on the right, you can see, for example, one of the problems that we encountered in the analysis of this data and then in the production of reliable counts. As you can see here, sorry, on the right, you can see in the red square the location of the device and several different factors involving the correct detection of a passerby. If you want to know more about this, I suggest you to read the references. I will leave this presentation for you to have a look at. There is an interesting paper published by James Cheshire and Bala Soundaraj, which was my predecessor at the CDRC. New technologies involving footfall sensing is the recent ultra-wideband radar. And in a recent grant and a collaboration project between local data company and UCL, we have started using and installing and receiving data from devices exploiting ultra-wideband radar technology that is a little bit more reliable. It has also a shorter range than wireless, and we are receiving data since 2019 with this data. With the ultra-wideband counts. The number of devices available is a bit lower compared to the SSS sensor, but we are preparing the data on the CDRC website. Now we're going to talk about some data that are more similar to the one presented during this talk, and basically the in-app or GPS phone data. So first of all, this data have been acquired through a commercial provider called ACK, and they are now, through the data licensing agreement, stored in a secure research environment held at UCL. So these data have been used to create activity tiles, basically, and a paper has been produced in the Financial Times by James Cheshire and one of our PhD students, Terry Strasberg, that is basically analyzing the activities of people during the COVID main important dates, as the one described in the previous presentations. Here you can see the link with the papers here in at the end of the slide, and available now. We have an aggregated data product that I will present later. So our work with this data has been in the creation of a national footfall index, being able to assess problems related to retail location or more in general activities in front of the shop, and answer questions like, for example, the death of the high street, or more relevant to the second line of work, economic recovery during pandemic, for example. And this leads me actually to the second stream of research that has been completed, I would say, successfully. I would say last week. Jacob, I will explain you why later, and is on assessing basically mobility impacts by COVID-19. So for this, we have been working with a pool of 4 researchers, and we have been involved in a local data spaces project, analyzing human mobility during COVID and providing reports for local authorities for all of England. On the last line of research, I will talk about footfall and in-app data fusion. So what we want to work on is something that is similar to what we was described in the previous slide, because we are going to have, I think, an interesting collaboration with Alessia. So the idea is to create a research-ready data product that is capable of providing a reliable measure of human mobility, generalized to all the UK population. So as you can know, this is entails a series of problems that have been discussed today, validation, for example, coverage, generalization. There's quite a lot of work in this direction. And as CDRC, we need to work on a reliable and robust methodologies that have to be coupled with the data that then we will provide, because we create the data for research, and for that we need to be able to couple reliable and robust measures of uncertainty. This leads me to our work, so related to the COVID and footfall. This is part of our actually dashboard for the visualization of our footfall devices. As probably we were able to see from previous presentations, visualization is very important in this domain, and sometimes we have to deal with big data sets. So this is an example, and for one that wants to know, this is Apache Superset. an example of our device browser that can allow us to see just a quick representation, an example of how Footfall measurement has been behaving during, in this case, you can see is the COVID period, the slash of the COVID period, especially the first instance. Same here, some examples of the performances by cities and so on. Behind this, there's a series of aggregations that has been done for the devices that are actually located at a specific shop. This is something related instead to the paper that was that has been produced by James Cheshire and Thierry Strasberg using the aggregated hack data that I described before, providing counts of activities by square. So, and this is an example, and by day, of the data that is that has been produced. We used here as well Superset for having a quick visualization of the time series and of the patterns. And linked to this using profiling and linking, like a typical approach that has been described before as well linking social demographics. So in this case, our bespoke retail center classification allow us to see the different behavior of our different retail centers during, again, a slice of the COVID-19 pandemic restriction time. Right, this is our last slide. And so I presented here what we have been working on at the CDRC involving human mobility. And I kindly ask you to have a look at our website, data.cdrc.ac.uk. There you can find some data products that I describe here today already available, like the research aggregated dataset for the smart street sensor footfall. This is quite a hit. A lot of people are using it. For this, you need to apply for. We also have a aggregated in-app location dataset available now. We also have the local data spaces reports available, and also all the reproducible code that has been produced to create the reports. The local data space is just a shameless product placement. Has been awarded as the best research excellent award for 2021. Quick conclusions. I think more comments than anything else. I was very impressed by the presentation and our work on the creation of this data fused mobile phone enhanced data set. I think is going to be complex. We are already collecting several covariates that needs to be used. I think we're going to have to develop some bespoke heuristics, but I think today some quite interesting libraries available. Two remarks that I see. Most of our work has to be conducted in safe research environments, which means that we need to use a separate environment to work on that. And sometimes the installation of software has to be mediated with the manager of such environment. And this sometimes can create some problems, can create some obstacles. So it's something to be taken into consideration. And that's it for me. Talk to us. We are available here on chat, myself and also Jacob, and have a look at our website. If there's something that might be interesting for your research, please apply.
Thank you, Maurizio. And there are some questions that are coming in from one of the panelists.
Yes, please.
Questions here. And one of them is, what do you think, how do you think sensors data compares to smartphone data, and what are the challenges in dealing with
yeah, thank you for the question. Well, let me stop sharing so you can see my face. Well, first of all, there are the usual elephant in the room, right? So representativeness, sample bias. We are actually using a particular type of devices that is already biased, and we accept it. We look at retail location, for example. So how good is our sample? It's the usual issue over here. So what I can say is that for our Wi-Fi that is more, let's say, volatile because of the technology itself, we need to take in consideration quite a lot of issues related to the number of people who owns a phone, for example, and so on. But that was done at a single device level. We have had problems, for example, in measurements that were related to the update of the operating system, Android versus OS, for people who understand the randomization of the MAC address. That makes difficult to identify a device. So in that sense, there are a lot of, let's say, caveats to take into consideration when modeling this type of data. Now, the ultra-wideband radar are slightly more reliable in the sense they are calibrated as well. The Wi-Fi footfall data have a series of manual counts that can be used to calibrate those. But in a sense, I think that once we provide the metadata, we provide what you actually get, the operating times, the manual counts, and so on. These are all elements that can attenuate and alleviate the bias that we described before. For the mobile phone data is the same discussion that we have been doing for, I think, all afternoon. We have those one as well. We have problems of assessing and, in a sense, probably embracing it, you know, like the MAUP that we have in GIS. We acknowledge it, we need to measure it, we need to quantify it and provide it as a CDRC, provide it as a, you know, couple metadata and additional data to the user so that they can understand what is it. And for the calculation of such bias, well, we generally use some of the techniques that have been described here. I would be interested in is using something else, because some techniques are also related and linked to the publications, because most of the data that we produced are linked to a publication as well. So sample bias and all those coverage, you know, reliability and so on are all these measures that have to be accompanied with the standard metadata, with the data, then the research rate, the data product that then we provide.
Thanks. Thanks a lot. And
can I add something here instead?
Yeah.
Just you know, something that I have just seen here. It you know, talking about safe research environment, dealing with people that have to install software and all of this. I noticed that there is some sort of divide here about in the programming language used in trajectory analysis. I come from a different, slightly different world. There was the world of fishing vessels. I will use a similar type of data like is described here, probably a little bit more regular. And for that, I thank God. But there, I am an R user, R and Python, but I use more R. And I noticed that most of the work described here, the algorithms, the published libraries are all in Python, or most of them. And there is a division. So Palma's work is in R, Pappalardo, Spaccapietra, and all of these others, and also the ETH is in Python. It's rather interesting, this division that is actually here. And if I'm wrong, please, panelists and other attendees, tell me I'm wrong. I do not stand corrected.
Well, if anyone wants to answer or carry the conversation in the chat, there is one question for Jacob as well, and that is how do these data sources, what's the plan for these data sources to fit into the future research plans?
Yeah, that's a good one. So right now what we're working on is, in addition to all the validation and the bias assessment and that, we do want to actually use these for proper kind of well-developed research studies. So what we're working on now is an analysis of park spaces, open green spaces, and then also to a lesser degree, retail centers. So we work a lot on retail centers, so that's kind of a byproduct. But the main project I'm working on now is coming up with a kind of gridded, tessellated version of all open spaces in the UK, across the major urban areas of the UK. And once we have kind of very gridded, tessellated, so these are hexagon geometries, then we're going to be able to overlay all of our mobility measures. So mobility density, attractiveness, and looking at where we have the highest concentration of mobility in park spaces, and specifically what's driving these, because we have park spaces across the entire country, we have mobility across the entire country. Again, focusing a bit on urban areas where we're going to have the accurate density that to kind of support the analysis. But we'd really like to look at how has mobility in and around park spaces at the granular level. So not just at the aggregate park, but at the borders of the park, or at the boundaries, or at the access point of parks. How is that conditioned on local amenities? So what's nearby the park? What's attracting people to these parks? And then specifically, we'd like to focus on COVID as well, because we have some of the mobility data, the HUC data, goes over the period of a few of the lockdowns. So we'd like to kind of cross all of that to look at how has the mobility signatures changed over time, specific to different lockdown regimens across the country, to different kind of stringencies of the local lockdowns, for example. But, so that's where we're starting, but we see, like I said, this can be used to explore dynamics and mobility around retail centers, around transportation hubs, again, taking into account all the validation and stuff which is going on in parallel. But in terms of actual research, the content, we see, any number of really interesting applications for this data. So apply and help collaborate with us.
Great. Thanks a lot. Are there, I'm not seeing any other questions on the chat. And so I can hand it over to Alessia for the closing.